Starting the recording. So Arno, today we are doing bonding, right? Chemical bonding.
Yeah,
Okay. So for chemical bonding, let us first understand what are ionic bonds and covalent bond. Okay.
yeah,
So if you see the differentiation over here, whenever we say ionic bond is generally between a metal and a non-metal,
right.
correct? Whereas a
Yeah,
covalent bond is between a non-metal and non-metal, right?
yeah,
Ha- what happens in an ionic bond is a metal lose an electron, okay,
okay.
and a non-metal gains an electron. So if you look at the electronic configuration of sodium, sodium is 1s2, 2s2, 2p6, 3s2, correct?
Yeah,
Sorry, 1s2, 2s2, 2p6, 3s1. I think I told you 3s2, right?
yeah,
And for chlorine, it is 1s2, 2s2, 2p6, 3s2, 3p5. Okay. Uh,
yeah,
you might have learned about the electronic configuration as the number of electrons in the orbit. First orbit has two, second has eight, and then one. So 281 you might have learned,
yeah,
right? And chlorine has two, eight, and seven. Correct?
yeah.
So basically, and you are you aware about the octet rule?
Yes, sir.
What is the octet rule?
Octet is an atom wants to have its full valence last shell uh, to be completed. So first shell has two and the rest have eight. It wants
Right.
to have that so it is balanced.
Okay.
Sorry.
So
Yeah.
yeah. So octet rule is basically what I generally call eight as the magic number. Okay.
Right.
If any atom is able to attain the magic number of 8 in the valence shell, okay, it is more stable.
Right. Okay.
Okay. What is the magic number? 8. That is
Eight.
what is the octet rule. So an atom will try to attain that magic number in its valence shell. It can
Okay.
either attain that by giving electrons or by gaining electrons.
Right.
Correct? Now, in this case, you need 7 electron if you have to fill it.
Yeah.
In this case, you need 1 electron to fill it.
Right.
Correct?
Yeah.
But it's very difficult to get 7.
Right.
Correct? It's
Yes,
difficult
sir.
to get 7, but it is easy to get 1. Right? And if you see the inner shell of sodium has 8.
Right,
Correct?
sir. Yeah.
That means its octet inside orbital, that is the second orbit, already has 8 electrons. So what it does, it prefers to lose this 1 electron.
Okay.
When it loses that electron is picked up by chlorine.
Okay.
Okay, so this becomes Na plus and this becomes Cl
A
minus.
minus.
So these are now cations and anions. They come together to form ionic bond, which is nothing but an electrostatic force of attraction.
Yes, sir.
Does that make sense?
Yes, sir.
Any doubt?
No, sir. Good.
Okay. On the other hand, if you have non-metals, both the non-metals are interested in gaining electron because generally non-metals have more than 5 electrons in them. Let us take example of chlorine again, right? Because we know it is 287
Yes,
and
sir.
287, correct?
Yeah.
Okay. If I draw the Lewis structure of chlorine, so I draw the symbol of chlorine, right?
Yes, sir.
Right. And I can make 7 electrons. One, 2, 3, 4, 5, 6, and 7. So this is the Lewis structure of chlorine, correct?
Yeah.
So if you see, this electron is the one which needs a pair, correct?
Yeah.
So what happens in that case is the two chlorine atoms, they come together and they said that okay, let us share the electron.
Sorry, sir. Yeah. Yeah. Okay. They
Okay.
shared them. Yeah.
And this is what gives the bond. Correct? So now
Yeah.
you have 8 electrons over here, and now you have 8 electrons over here. So if both of them cannot give and take, like because they are having 7 electrons each, right? They cannot give and take, right? So they
Yeah.
prefer sharing. And now this octet is complete, this octet is complete. That is what is a covalent bond, which is formed by sharing of electron. Okay, can you make a note of this, both the
Yes, sir.
concepts?
Yeah. Okay, sir. Done.
Done. Okay, so remember that part. uh, right, so this is what happens. Can you actually, I should make it in terms of Lewis structure. I should make this better. Okay, so I have Na plus, right? Because the electron is lost. Chlorine has taken that electron, right? So now chlorine has this structure, okay? And it has
Yeah.
a negative charge. So this becomes the Lewis structure of chlorine. Although I'm making the pairs this way, that is not the rule. The rule of Lewis, writing the Lewis symbol is what? So you write the symbol of the element and then you go clockwise or anti-clockwise to fill the electrons. Okay,
Okay.
so now there are 8. So I filled the 8 electrons in a clockwise manner here. Okay,
Yeah.
so this is what should be the structure. Can you draw that?
Yes, sir.
So copy this to sodium. What happens to it? So 2 8 here, and this is 2 8 8. So because and you understand this, right? Because there are less number of electrons, there is a positive one charge. Here there is one more electron, so there is a negative charge. Is that understood?
Yes, sir.
Yeah.
Okay, sir.
Then
Done.
that's done. Then after that, okay, I think I told you about Hofbrinkels earlier,
Yes, sir.
right? Okay, extremely important because all the Hofbrinkels are diatomic in nature, right?
Yeah.
So have you copied this earlier?
Yes, sir.
Okay, no doubt with this, right?
No, sir. All good.
Okay, now let us understand another concept, that is electronegativity. Okay, so
Yeah.
what is electronegativity is, write down the ability to pull electron, the ability to pull electron,
Okay.
right? It's the ability to pull electron,
Okay.
right? In a
Yes.
pure covalent bond, in a pure covalent bond, or in a covalent bond is also fine.
Okay.
Now you understand this is chlorine, right? So chlorine, we form the molecule by sharing electrons, right? Each of them, like they had seven, one, sorry, uh, I say one, two, three, 4, 5, and 6, right? And the other of chlorine, 6, 7, and 8. Yeah, so this was the structure, correct?
Yeah.
Now, the electronegativity of chlorine is around 3.16, and this also 3.16. That means they have equal pull,
Right.
correct? Because they have equal pull, what happens? The electron cloud is equally shared between them,
Okay.
right? So, what happens? This bond is called as pure covalent bond. Okay,
Yeah.
can you write this?
Yes, sir. 1 second.
Electronegativity is what? Ability
Electron
to
ability to attract and hold electrons.
ability to attract electron in a covalent bond.
Yeah. Okay.
And there is a formula of delta En, that is ENA minus ENB, where A and B are the atoms. A is always the atom which has greater electronegativity than B.
Yeah. Okay.
Okay, done.
Yeah.
Okay, so have you written down this formula?
Yes, sir.
Okay, now can you calculate delta En for chlorine?
It would be 0, sir.
0. So if it is 0, that means the electron cloud is equally shared between the two chlorines, correct?
Yeah.
Now let us see over here in case of HCl. The electronegativity of hydrogen is 2.2, and that of chlorine is 3.16, correct? Now what is the delta En?
Uh, 0.92, sir. 94.
9. Okay, 9496, that's fine. So you got 0.9. Now that indicates that the electron cloud is not equally shared.
Yeah.
When it is 0, it is equally shared. Because chlorine is more electronegative, the cloud is more towards chlorine,
Okay.
right? Because the cloud is more towards chlorine, chlorine has a partial negative charge and hydrogen has a partial positive charge.
Okay.
Okay, this is what is called as polarization of covalent bond. Okay,
Yeah.
so and when you put an arrow from positive to negative between the two dipoles, this is what is called as dipole moment.
Yeah.
Okay, can you draw this?
Yeah. Okay.
Done.
Yeah.
Okay, so that's done then. Understood this?
Yes, sir.
Okay, now let us understand what is the range when we can say that okay, something is polarized. So for that range, write down this 0 to 0.5, 0.5 to 1.70, and 1.70 and above.
Yeah, okay.
Okay. So if the difference is between 0 to 0.5, okay, then we call it as covalent. That means we say that the difference is negligible. Electron cloud is actually equally shared. But if the
Yeah,
difference is greater than 0.5 to 1.7, we say that okay, there is a shift in the electron cloud towards a more electronegative atom. That means there is polarization.
yeah,
Okay, and that is what is called as a polar covalent bond formed by sharing, but the tilt is towards more electronegative atom, so we call it as polar covalent. But if the difference comes 1.7 and higher, right, generally
yeah.
this difference is between metals and non-metals,
Right. Okay.
generally speaking. Okay, so those are, that means the electron is completely moving and going to the electronegative atom, right?
Yeah.
Understood? So we
Yes,
call
sir.
it as ionic bond. So for the sake of simplicity or understanding, if the difference is 0 to 0.5, it is covalent. If it
Okay.
is between zero point 0.5 to 1.7, polar covalent. If it is between 1.7 and above, it is ionic.
Okay, sir.
Clear? No doubt, right?
Yeah.
Okay, yeah. And if you see, I have written 0.4 to 0.5. Why I did that is because there are books, there were older books when I used to refer during my study, right? There was a range like 0.4 to 0.5.
Okay.
Okay, but I believe the newer books are all 0.5. Okay,
Okay.
now uh, next part that we should understand is there are elements which have expanded octet. Okay, do
Okay.
you do you know what is an expanded octet? Have you heard about expanded octet?
Yeah.
Okay, so basically, what can you tell me what it is?
Expanded octet. There are more. What do you call it? I believe it's more electrons in the outermost shell.
Like yes, it is more electron, but more means
More
two
than eight.
can more than eight. Yes, that's right. And what is incomplete octet?
There are not eight electrons.
So there are less than eight electrons,
Yeah.
right? But still they are stable. Okay.
Yeah.
Now what I want you to do is I want you to draw the Lewis structure for PCl5, BeCl2, and BF3. I want to know whether are you able, like, are you comfortable drawing Lewis structures?
Yes, sir.
Can you draw it?
Yeah, sure.
Yeah.
Where would you like me to draw, sir?
Draw it on your book and share the image with me on WhatsApp.
Okay, sir. What elements?
Sorry.
What element?
B PCl5,
CN5. Okay.
then BeCl2,
ECR2. Okay.
and BF3.
BF3.
Yeah,
Okay. Lowest dot, right, sir?
Lewis dot structure. Yes. Done.
Almost, sir. 1 second. I don't remember how to do the like if there are more than 8 electrons, but I'm doing the other ones. 1 second.
Sorry, you said something and I missed it.
I don't remember how to do when there are more than electrons.
Just make the okay. How many are there for phosphorus?
Phosphorus, there are five, sir.
Five,
Six.
right? So
Yeah.
for
Uh,
each electron, add a pair.
okay.
So that will make it 10.
Yeah.
So that is what is the simple way. I'll give me 1 minute. I'll draw it. First, you complete and send it to me.
Yeah. Okay.
Okay.
Okay, sir. Set.
Yeah, I've saved it. Okay. Yeah, I'm checking it. Okay, BF3 is fine. Okay, PCL5. You haven't made PCL5, right?
No, sir. I forgot how to do that.
Okay, no problem. I will just share my screen. Okay, so BCl2 is correct, what you drew. That is fine. BF3 is also okay, right? But there is one thing when you draw BF3. Try to make them equidistant,
Okay.
right?
Okay.
Okay, so this would be better. There is a rule called as valence shell electron pair repulsion theory. Okay, which says that electrons move as far as possible from each other. Okay,
Okay.
so that is what is that you'll learn later on. But for simplicity, just remember to put them as far as possible from each other. Okay, like
Okay.
here you did it over here. You could have made BeCl2 this way too,
Yeah.
right? But you didn't do that. You made it far away from each other.
Yes, sir.
Correct? Okay. Now let us talk about phosphorus. How many valence electron phosphorus has?
Phosphorus has seven, six, five, sir.
Five, right? So you made this as a Lewis structure. One, two, three, four, and five. Am I right?
Mm-hmm.
So when you do the pairing, what you do is because it is PCl5, right? I will draw 5 chlorine as around it.
Okay.
Okay. I will give the pairs between them.
Okay.
Okay. And then I'll complete the octet of the outermost element. Oh, I forgot here. Okay.
Okay.
So there are certain rules. I'll explain you the rule. First rule is you need to calculate total valence electrons.
Uh-huh.
For phosphorus, it is 5
Right.
multiplied by 1. For chlorine, it is 7 multiplied by 5. So we have 5 and 35. So
Right.
we have 40 valence electrons.
Right.
Correct?
Yeah.
Any doubt?
No, sir.
Okay. Now Second is one is total valence electrons, and the other one is what you say is we call it as total valence electrons, and other is total electrons. Now, total electrons are basically phosphorus. For its stability requires 1 into 8, correct?
Right. Yeah.
And chlorine requires 8 into 5. We keep, sorry, I'll write 5 into 8 here, correct?
Yeah.
So you need 8 and 40. So total you need 48 electrons,
Yeah.
correct?
Yes, sir.
Am I right with 48?
I
40, yes.
believe so. Yeah.
Mm, Let us not use this method as it will further complicate the. Okay, you let us use not don't use the total valence electron. I'll use it sometime else. Okay,
Okay.
so just use total valence electrons, right? So those are 40, correct? So first we calculate the total valence electron. Second we do is we calculate or find the central atom.
Okay.
What is the central atom generally? The one which is least in this molecule.
Okay. And how
Okay,
would that be? Oh, okay. 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 I understood.
PCl5. So there is only one phosphorus,
Right. So it's
right?
in the center.
Yeah, but we can also have HNO3. Hydrogen is one and nitrogen is one, right? So there is
Right.
a tie. So hydrogen and fluorine or fluorine are monovalent. Okay, means they will
Okay.
never be central atom.
Okay.
Okay, so first is to calculate the total valence electron. Second is to find the central atom. Correct?
Yeah. Okay.
Is that understood?
Yes, sir.
Okay, so after that, what we do is we draw the central atom first. Okay,
Okay.
and then we draw 5 chlorines around it. So third step is you draw the central atom.
Yeah.
Okay, and then you surround it by the extreme atoms or external atoms.
Okay.
So we have one, two, three, four, five. So I have tried to share, like disperse them as far as possible from each other. Okay, I did
Yeah.
that. Now what I do is I there's once that is done, the next is shared pair, shared pair,
Okay.
or you can say draw shared pair. So these are the shared pair. One, two, one, two, one, two, one, two, one, two. Okay.
Okay.
So are we done with? So 2 and 5. So total there are 10 electrons done. So still 30 electrons are remaining. Correct?
Yeah.
7 fives are 35. Yeah. Mm, right. And still 30. So what I'll do, I'll start completing the octet of chlorine. So 6 for one and the octet is complete.
Yeah.
6 for the other and the octet is complete. 6 for this and the octet is complete. 6
Right.
for this and the octet is complete. 6 for this and octet is complete. So 6 multiplied by 5, 30, right? So
Right.
your Lewis structure for PCl5 is this, correct?
Yeah.
Done. And yeah, obviously here you can also represent the shared pair, sorry, lone pairs.
Okay, sir.
So these are lone pairs. These are all called as the lone pairs.
Okay.
Okay, because they are not bonded to any other
Right.
atom.
Okay.
These all are called as lone pairs. And the one I drew straight line are the shared pairs.
Okay, sir.
Done?
Yes, sir.
Okay. Now what I want you to try is SF6.
Yes. Six. Okay.
And share the image. We'll stop
Yes.
here.
Okay, sir.
Yeah, I will see. Okay. So I see that you have made it correct. Instead of making the clouds, right, it's better you make the lines there.
Okay, sir.
Hmm?
I'll do that instead.
Because generally the shared pair are represented by a bond.
Right. Okay.
Okay, so it's better to represent this by bond.
Okay,
Apart from
sir.
that, all is good, right? There should be 12 in the center. Yeah, you got 42. Yes. I wanted to like the other rule that I was going to tell you, 1 into 8, that requires octet, right? And
Yeah.
6 into 8. So let us try that. So we get 8. I had learned that somewhere. I don't remember. So 8, 8. And what is the number I get now? 56.
Yes, sir.
Okay, now if I do t minus, so let us say this was v and this is t. Okay, so if I do t minus v, right?
Yeah.
So I get the number as, yeah, I get the number as 56 minus 48. Correct? Getting number 8. That is what is the problem. I should get number here as 12 because there are 6 bonds, right?
Yeah.
There's an expanded octet. So yeah, so it's not, this formula works when there are like, I think when the rule is what do you say, when it's not an exception.
Okay.
Okay, so when it's not an exception, it will work where it will give us the number of bond like shared electron bonds.
Okay.
Okay, let us try that like in some other example. Okay, let us try it for now. CF4.
CF4. Okay.
Yeah,
CF4 works, sir. It's a what do you call it?
carbon tetrafluoride.
Yeah.
EF4.
Yeah. That has It's not. It has eight valence.
Yeah, that's fine. So just make the structure.
Okay, sir. Okay, so silent.
Uh, there is one mistake.
Yes, sir.
There is one mistake. Let me show you. Can you see the screen? Do you know what the mistake is?
Uh, 7 electrons. Oh, I forgot
Yeah,
that side. Sorry. Yeah.
yeah. But so basically, you got the total. Okay, the total electrons. The valence electrons are 1 into 4 and 4 into 7.
Yeah.
4 and 28. So it should be 32.
32.
Correct? But
Yes, sir.
T should be 1 into 8, 4 into 8. Correct? So
Yes, sir.
I have 8 and I have here 32. So the number should be 40. Correct? So S is T minus V. So 40 minus 32, which is
8.
8. And 8, so bonds are S by 2. So 8 by 2, which is 4. So you have 4 bonds.
Okay.
Correct? So this is also another way, but it works only when you have if you don't have expanded octet.
Okay.
Okay? Can you write down this calculation too?
Yes, sir.
T is valence electron, T is total electrons, or what do you say? T is a hypothetical thing, right?
Yeah.
Okay, so like maximum 8 electrons are required for fluorine and 8 are required for carbon for the
Okay.
octet completion.
Okay, sir. Done.
And okay, now try NO3 minus.
No, 3. Okay.
So so N 1 into 5, oxygen 3
5,
into 6.
18,
So we have 5,
23.
18, 23, right? But you
Yes.
have one negative charge, so you will add one electron.
Right.
So
Okay.
so 1
Plus
into
1.
1, that is 1, so
24.
total 24. So uh, your number of V is 24.
24. Okay.
Okay.
And
Now
then T is still 1 times 8 and then
1
3
times
times
8,
8.
3 times 8. So you have 8
32.
and 32.
Yeah, total 8 is 32. And then S is.
Are you sure? No.
No,
Yeah.
that's 24,
Oh,
sir.
my
Total
bad.
is.
Yeah.
Yeah.
Yeah. Total is
Is equal to
32.
T minus V.
S is T minus V, which
32
is
minus
8.
24. And then bonds is divided by 2, which is equal to 8 divided by 2, which is 4.
So there are 4 bonds, correct?
Yeah.
So now you know central atom is nitrogen.
Yeah.
You make 3 oxygen which are away from each other,
Yeah.
correct? So
Yes.
you make nitrogen and you make 3 oxygens, right?
Yeah. And then one of them has a double bond, right?
Yes. And
So 1, 2, 3, 4, 5, 6, 7, 8, uh, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wait, 1,
yeah,
2,
so
3, 4,
this
5, 6,
is
7, 8,
center.
9,
At the
10.
center you have 8. Here oxygen, can you see this oxygen here?
Yeah,
That is 4, and other two oxygens are 6 and 6.
yeah, okay.
So you have 24,
Okay,
correct?
yeah,
Okay, now if you notice, these have 3 lone pairs. 1, 2, 3. This have 3 lone pairs,
yes,
correct?
sir.
But this will have 2 lone pairs because there is a double bond.
Okay,
Okay, would you like to try SO3?
yes, sir. So, 3. It has 4 bonds, sir. Okay, sir, done.
T is 1 into 8, 3 into 8, 8, 24, 32. So again you got 8, so you might have drawn this structure, right?
Yes, sir.
There is a basic problem with this that I know that the formula doesn't solve it. Okay, now in the previous structure too, right?
Uh-huh.
Okay, here if there is a concept called as formal charge,
Right.
you don't have that in this grade. Okay, so
Uh-huh.
a simple way to remember formal charge is that if you see 3 lone pairs on oxygen,
Right.
that is one negative charge.
Okay.
And that means there are two negative charge on this molecule, correct?
Okay, yeah.
That means the sulfur is plus 2 charge.
Yeah.
So if this is the structure, it is slightly unstable.
Okay.
Okay, so how we can avoid the formal charges, and because sulfur belongs to period 3 and above, so it can have expanded octet,
Okay.
correct? If you
Yeah.
keep it where you got, if you keep it there, I don't think so your teacher will say that it's wrong. But
Yeah, we haven't been taught this.
yes, but the thing is, like if you google, you will come across this structure for
Right.
fluid structure. That's because if formal charge is known to you, you're supposed to calculate the formal charge and come to a structure where the formal charge is 0 on each and every atom. So here it is 0, here it is 0, here it is 0, and by default here it is 0.
Okay.
Okay, what did I tell you? Simple way to remember for oxygen: if you see 3 lone pair, means there is minus 1 formal charge.
Yeah.
Okay, so but in this structure that I have made, there is 0 formal charge, so that means this is more stable.
Okay.
Okay,
Got it.
now, okay, is that clear?
Yes, sir. Clear.
right? Uh, and okay, when to use expanded octet? I need to cover that.
Yeah.
When can we have expanded octet? We can have expanded octet when we have period 3 and above.
Okay.
Period 3 and above elements.
Okay, sir.
That means it starts from sodium.
Yeah.
Okay, sodium and ahead, we can have expanded octet.
Okay.
Before sodium, we
We
cannot
can.
have expanded. Either it is complete octet or incomplete octet.
Okay.
Because from sodium, if you see sodium position, it is third period, right? Third
Yeah.
period means three shells or three
Yeah.
orbits. If there are three orbits, that means there is a space for expansion of the octet.
Okay, sir.
Okay, I am not
Wait, why
going.
is that, sir?
Okay, so there is a concept called as hybridization in grade 12.
Okay.
So you'll learn it over there.
Okay, sir.
Okay, any doubt till here?
No, sir. All good.
So expanded octet when to use and incomplete octet when to use. Is that understood?
Yes, sir.
Okay, good. So we did all that thing. Okay, I've already covered this part. Okay, now let us understand this. So now I want you to draw the structures for CH4, CHCl3, CCl4, H2O, and NH3. Draw the Lewis structures because I'm coming to the next concept of that.
Okay, sir. Sir, how would a CH4 be if there are only two bonds? Oh, wait, sorry. I did something wrong.
Sorry, I was on mute. For
I did something wrong,
carbon,
sir.
it is
It's okay.
8, and
Eight.
hydrogen, it is 2. Because to complete the octet, sorry, you need a duplet for hydrogen.
How does that work, sir? I am not.
Okay, so because hydrogen belongs to period 1,
Yeah.
right? For period 1 or the first orbit, you need only 2 electrons. So if
Okay.
hydrogen has two electrons, it is stable,
Yeah.
right? It needs electronic configuration of helium. Helium has only two electrons,
Yeah.
right? So carbon is 1 into 4, hydrogen is 1 into, sorry, 2 into 1, correct?
Yeah.
So total you have how many? So sorry, 4 into 1, right?
Yeah. 4 into 1.
So you
That's
have,
8.
yeah, so 4 and this 4, so you have 8, correct? So you
Yeah.
have carbon and then you have hydrogen, yeah.
Yeah. Okay.
And if you want to try that formula T, right? T would be what? Carbon 1 into 8 and hydrogen would be 4 into 2.
Yeah.
So that would be 16.
Yeah. 16.
So if you do the T minus V, it will be still 8 and you know that there are 4 bonds.
Yeah.
Okay. Try it for this.
Yes, sir. 3.
Has your school covered like intermolecular bonding? Is that concept covered?
Intermolecular bonding, as in what, sir?
As like Lewis structure is covered for you in the school, right?
Yes, sir.
Okay. And has your teacher taught you about the way I taught you about the bonds and the other stuff?
Yes, sir. We went over covalent, ionic, and metallic.
Metallic. Okay. And you didn't do the Lewis structures.
No, sir. Not yet. I believe
Okay.
that's for tomorrow or the day after.
Okay, no problem. And then I've covered most of the things.
Yes, sir.
I've also covered the polarization, so that is good. Okay, you
Yeah.
do these structures and then we should be good then.
Yes, sir. I'm working on it. 2 times 8 to and H2O, right, sir?
Yeah.
Okay.
Okay, Arnav, do one thing. You complete all this and we'll continue in the next class.
Okay, sir. Once again, I'm just going to write it down
Yeah,
and I'll send these to you on WhatsApp right
no
now.
problem. That works.
Okay, sir. Thank you.
Yeah, bye.
Bye.